Last section we're going to look at is blocking. And the idea of blocking is to get people with similar traits spread out amongst the different treatment groups to make the groups as similar as possible. In a typical experiment, the goal or hope is that all the subjects are roughly similar. And that way, no matter how we split people up, the treatment groups will be very comparable. There's not going to be any lurking variables or confounding going on in our study. However, in reality, there are lots of things that make our different subjects different, and some that we know about ahead of time and some that we may not. We hope that random assignment is going to make the treatment groups similar enough. That's something we had talked about much earlier, that if we randomly mix people into different groups, we hope that that will make the two groups, or however many groups we have, as similar as possible. However, as you can see in this particular iteration, when we randomly mix people in different groups, we ended up not having super different or super similar groups. We actually have quite a big difference between this group and this group here. So what we're going to do is first match them up into groups of similar groups that are similar under some characteristic that we want to study at least, and then we will break them off into treatment groups. So here we had a bunch of people kind of mixed up. We paired them up in twos in this case. Sometimes we'll use a different number than two, and I'll explain when we would do each of those. But we form these different groups, we call them blocks, and then we sort them out into the different treatment groups. The size of the block, the number of people in the block, is equal to the number of treatments. So over here we have blocks of size 2. We have 2 subjects in a single block. That means that in this study we must have had 2 treatment groups. If we had 3 treatment groups, we would need to have 3 people per block. That's an important thing to remember. The number of people inside of each block is the same as the number of treatments, because we're going to send one person to one treatment group, the other person to the other treatment group. And so if there were 3 treatment groups, we'd need to have 3 people in each block. So let's look at an example and see if we can do this. The goal is to get all these people into treatment groups eventually. The blocking is kind of the middle step that we'll go through. We're going to assume in this example that we have 3 treatments. We have a placebo, we have an existing drug, and we have the new drug. And those are the 3 things being compared. If there are 3 treatments, that means there are 3 subjects in every single block. The size of the block is the same as the number of treatments. The total number of subjects in this little example here, we have, if we count them up, we have 12 people over here to work with. So that means the number of blocks, not the size of each block, but the number of blocks would be the total number of people we have divided by how many people go in each block. That means we're going to end up with 4 blocks. So we have 4 blocks, and we need to separate these people into 4 blocks. Now, the way we do that is not to number them and randomly put them in to each block to say, okay, this is person number 8, we randomly chose 8 to be in block 3. The idea of blocking is to get people that are the most similar paired up together, matched up together. So let's go ahead and take all the sword people here and put all of them in the same block. The idea of blocking is to get similar subjects or similar experimental units together first. Then we're going to separate them off into the different places. So we'll take the 3 sad people here and the 3 happy people here. So first we make similar blocks. Next step is we need to get those people in each block into the different treatment groups. Now that we do randomly. We can't just say, oh, first person in the first group, first person in the first group. We want to make sure we're still randomly assigning people. But we're going to do one block at a time. So we have 3 people in the block. We need to go to our randint to randomly choose one of those 3 people to go into our placebo group. Go to math PRB, number 5, randint. And we're only generating numbers from 1 to 3 now. And it says person 2 we chose. So we take person 2 and throw them into our placebo group. We still have 2 more groups to work with. We have our existing drugs and our new drug. So let's go ahead and do it again. Alright, person 3. So that leaves person 1 to be in our last group. So that's how we randomly assign the first one. Now, let's go ahead and do it again. We have 1, 2, and 3 in block 2. So we randomly generate a number, 2. So 2 goes right here. Do it again. Okay, we have a repeat, 2, 1. Alright. And then 3 would go over here. And you keep doing that. You keep randomly generating numbers to determine which person goes into which block. And let's say we got 3, 1, 2, and we randomly generated numbers here, and it was 2, 1, 3. However it ends up. The important thing about blocking is that if you look at these groups, yes, these are people of different colors. They're all different people. However, we have 1 sword person in each group, 1 muscle person in each group, 1 sad person in each group, 1 happy person in each group. Whatever it was that we could sort people on the outside early on, we made sure that we blocked by that first, allowing us to make each of our groups as similar as possible. So the idea of blocking is to make all the groups as similar as possible, because we want this group, group 1, to equal group 2, to equal group 3, until we make them all different by giving this group the placebo, this group the existing drug, this group the new drug. Before that point, we want all the groups to be equal so that the drug is the only thing that's being compared, that's being changed in the different groups. Looking at another example with numbers here, we want to do an experiment on how well hard hats reduce head injuries. So the 2 treatments we're going to have is one group's going to receive hard hats, the other group is not going to receive hard hats. And our belief is that height might also affect number of head injuries. So we want to block by height. We want to make sure that there's people of similar heights in both groups. If there are 2 treatments, that means that there are 2 subjects that we're going to put in every block. And since this list of people over here happens to have 8 subjects, that means that the number of blocks is going to be that total number of people divided by 2 per block. We're going to end up with 4 blocks again. Thinking to the reason we're doing things, the reason we use blocks is that height, how tall someone is, might be a confounding factor. If we have all the tall people in one group, it might not matter if it's hard hat or not. They might sustain more head injuries just because they're tall and they hit their head on things all the time. So we want to make sure both groups have people of similar height, so that doesn't get mixed in. It's not because, oh, this group was taller than the other group. It's just because this group wore hard hats and this one didn't. That's the only thing we want to compare. So our blocks would be to take all the 2 tallest people, put them together, the next 2 tallest people, put them together, and so forth all the way down to the 2 shortest people. So our 2 tallest people looks like they are Tommy and Mike. So we'll pull them down together. Next 2 tallest, we have Frank and Jean. Then we have Amy and Brenda. And finally our 2 shortest would be Jamie and Meredith. These would be considered the blocks. So we have 1 block, 2nd block, 3rd block, 4th block. Now to get these people into treatment groups. We have them blocked by similarity. We have the most similar people in height blocked together. Now we need to split them up. To do that, you still have to randomly assign. You can't just send them to whatever group you want. Let's label Tommy as 1 and Mike as 2. And let's go back to our calculator. And we're going to have to do our randint again. Math PRB number 5 for randint. We only have 2 numbers, 1 or 2. So 50-50 shot. First one is going to be a 1. So we're going to send Tommy to group 1, Mike to group 2. Next number we generated was a 2, so Gene will be selected for the hard hat group. Frank will go over here. And you continually repeat that until all of your people have been randomly assigned. So make sure you're generating a random number for each separate treatment group. Then you will form group 1 and group 2, or group 1, 2, and 3 as in the previous example. And that is how you block.